Hello guys, in this video I would like to explain about Chow Test in Python, and I have explained Chow Test theoretically in detail, and also I implemented this test in R and R Studio already. There is a very good and detailed video on this topic in Chow Test in R. So if you want to know about the theory, the formula, and the detail behind this test, please watch the video. The link to that video is given in the description of this video, so you can go click and just watch that video, so you will learn that what is mean by Chow test. Because I will not go into detail, I will just implement this in Python now, but the detail is given there. This is full detail. I have wrote many things with the paper and the formulas and the how how this test work, and how the data, how we manipulate the data to implement this test. So all these things are given in that video. So just go and to the description of this video, click on the link, and you will see how you can how the background of this test. And once you know the background of this test, then you will be able to interpret the results easily. So let's see a little background of this test. I mean, just basics. This Chow test was developed, Chow test in 1960 by this particularly econometrician, you can say, uh, Chinese American economist Gregory Chow developed this test in 1960. Chow test is referred to as statistical tool to find the relationship between the coefficient of two different regression model. In addition, it is possible to find structural break at any point. So we will use this for structural break actually, that whether there is a structural break in the data or not. Therefore, it can be caused by factors such as policy change. Okay, the structural breaks can be any reason. We are not interested right now in that, but we can test whether a data has a structure change or not. You can see like this data, there is structure change here, very obvious structure change here. So when you test the data, and you will see, oh, there is a structural break. This is very obvious structural break. Maybe you can see some other breaks like this and this. So you can test the data, and then you will see whether your data has structural breaks or not. So you can test with the help of this test. You can test different policies. When there is a regime, one regime has ended and the other regime is started, so then you will see a break if some policies are discontinued or something like this. So you can test structural break, and you can say about the policies that whether there is a shift in the policies which impacts different economic indicator or not. So it's very useful test. You can use this in econometrics, in economics, finance, and maybe other fields as well, of course, actuarial sciences, and many others. So this is the formula which normally we use to test the hypothesis. And this SSR3 is, this is the sum of square for the whole regression model. If suppose we have data like this is the data from here to here. So we need to fit a regression model to the whole data. The whole data, one regression model to the whole data, and then we divide the data before structure break, after structure break, and then there is regression 1 to the first one and regression 2 to the second one. So we have three models. So then this is the whole overall model, and the sum of square of residual of this overall model, and then the first model before structure break and the second model. And then you can just use this formula, and you can test, and you can see the p-value, and the null hypothesis. You can see the detailed video, and the null hypothesis you can see, because I don't remember exactly, but I think the null hypothesis is that there is no structure break in the data. Or if you explain this in the other word like this, Chow test refers to a statistical tool to find the relationship between the coefficient of two regression models. So this means that when you have two models, like first model, second model, like this model and this model, So this means that you are testing that the regression coefficient of this model and this model are same. So this means that there is no structural breaks actually. This means that there is no difference in the coefficient. So let's see the null hypothesis as well, because I don't want to explain wrong things. Not unsure thing, not wrong things. Null hypothesis. And Chow test. The null hypothesis in the Chow test that there is no structural break in the model. So this is simple. I explained this already, but I was, to make 100% sure, because this content will be watched by many people. So this can, change their mind. So I don't want to present some thing which is, not sure even by very small fraction. So that's why I was wanted to see. So this means that there is no structural break if the coefficient of this regression model and this regression model is same. So this is the formula, and please watch that video. You will see these explanation of all these components. I don't want to explain it this again. So you can see each and everything is explained in detail in the video. The link is given in the description of this video. So now let's move to Python and see how this test work. Just open Anaconda and then Spider, and then yes, the code, the Python code. We need to wait little, as this will take little time. Okay, just wait a bit more. Okay, so it is now here. We are here now. Spider. Just wait a little more. Okay, so this is Spider now. Okay, and okay, no, so we need to open the Chow test. The code for Chow test in Python. So, okay, now we have the code. So we need to import these libraries and NumPy, pandas, and state models. That's important, and linear model as well. Remember that this code is very short code, and this in my computer this not work, but you can use if this work, because you need to use only one single command compare here. You need to use this command and this will work for you. If you want to use this code, the data is similar until here. All the steps are similar, but I'm using the other, so you can use any one of these two, no problem. That's okay. In the difference is that you need to import this and then use the compare command, and you don't need to do in detail, the sum of square up, like sum of square all, sum of square up 1, sum of square up 2, as I showed the formula in the figure the beginning, and then yes, do these things. You don't need to do these things in this code. Yeah, just you need to use this compare command. However, you can use this as well. Again, you need to yes, run this, import this, libraries, then just generate our data. This random, okay, this is just a random seed, and it's the 100 observation, and then X is like this data, and Y is just some manipulation with the X plus this one, and so we already have done many videos on generating data sets. So of course, you don't need to generate data because you will use this data on your real data. So you just need to read the file from CSV, from other format, or you need to do the data from. Also, you can have the data from online sources. So you just need to plot plt.plot. Just want to show you the y variable, how it look like. Okay, so there is plt, it should be plt, not pl. Okay, just see the plot. No. Oh, okay. So I need to also need to call the library that is used for plot like this one. So I need to copy this as well, and I need to call this as well, otherwise this will not work. So this is now okay. So now you can use this command and this will work. Yeah, that's sure. So this is now you can see the plot, and by the way, there is no structure break is not obvious. You need to introduce the structure break by using this one. You need to introduce structure break by using this step, and then you need to plot it again, and you will see the structure break. Yes, so you can see the structure break some here. This data is different than the previous data now. Okay, so these are predictor. You can also split the data into two parts, because now you need to divide the data into two parts, as I already told you, at the same point as we did, I think this look like the hop of the data. So we need to divide both data for two regression model as we discussed already. And then you need, if you want to add intercept terms, you can do like this, and we have done this 2-3 times before this in the regression analysis with Python. So you just need to add a constant in all models, and then you need to fit models to each data set, to the whole data set. This is for all data, this is for second data, and this is for first data. Add constant for intercept. Okay, this is not the model, this was just added. We have done this, so we need to do this now to fit the model. You can do this, no problem. It's working, it is working. Now you need to calculate the residuals, sum of square. Calculate the residual sum of squares. So you need to calculate this for each model, as I explained already in the beginning. Residual sum of square of the first model, second model, and the overall data. And then you need okay, number of parameters including a intercept. So this will give you the number of parameters. You need to know that as well, because that is important. And now you have all these things. So you have n, you have 2, you have k, you have rss1, you have rss2, and you have rss all. So just now, because this is the formula of Chow test. So you have everything. You can calculate very simply that how this Chow test will be calculated. So fine, that's working. Now you need to calculate the p-value of the Chow test. You already have Chow test. The Chow test statistic you already calculated here, and now you can calculate the p-value by using this formula, but you need this function. It's imported, and then calculate the p-value. And now you can print the Chow test and the p-value of the Chow test, that is statistic, and just look at this. Okay, so this is the test statistic. Okay, this is the test statistic of the Chow test. Chow test statistic is this one, and now you can print the p-value, and this is the p-value is very small. The Chow test statistic is quite high, 21.425, and the p-value is really small, 2.0265, e raised to the power minus 0.8, minus 8, so very small. So this means that we reject another hypothesis that there is no difference in the coefficient, like the two models. This means that the model here is different pyramid. Look at this model, this data is like smooth, not like this one. This one has trend is much higher, and the intercepts also different. So this means that the regression coefficient of two data sets, first data and second data, are not the same. So this means that there is a structure break in the data at the midpoint, because we created it at the midpoint. So this means that there is a structure break in the data. You can test any type of data which you think that there is structure break, so you can confirm numerically that whether there is a structure break or not by using Chow test. So this is all about Chow test, which have the application in particular in econometrics, economics, finance, actuarial science, and maybe in the climate science and hydrology and all other areas where you are interested. And particularly when you are trying to test the regime shift, the changes of the regime, the regime shift on different economic indicator. So this is very useful and powerful test to use to see whether there is changes or not. So I think this is enough for today. And if you have any question, remember that you need to watch the other video, Chow test and R. The link to that video is given in the description. The full detail, that video is almost for an hour, 60 minutes almost. So the detail is given in that video. If you watch that video, then this will be very easily understandable for you. So please watch that video. And okay, this is enough for today. Thank you very much, and see you in the next video. Ciao.